So, good evening and hello. I'm Rüdiger Wassibauer and I welcome you all to a Subnet Talk in November. The format is that we're going to have 25 minutes about Impulse and then 30 minutes of discussion. And I would like to welcome Philipp Wintersberger from the ITU Linz. And he works with intelligent user interfaces, and he's going to give us a talk about AI-assisted multitasking.
Wonderful.
Thank you.
Thank you so much. Thanks everybody for coming. Quite a good attendance for an already evening, I would say, but the Christmas market is not open yet, so I think that's good for me. I'm Philip. I'm a professor of intelligent user interfaces at ITU, and broadly speaking, a lot of the research that we are doing is circling around the question how we can utilize AI system to support users' productivity and well-being in often safety-critical multitasking environments, and we use different techniques to achieve that, like mixed reality simulation, human behavior modeling, or machine learning. Before I start, I want to say that it's not about me. Most of the stuff that you will see today is done by these great people, the group that is doing the work, and that I have the honor to present their work. And as I heard that this is less like a keynote talk, it's more like also discussing with you. I brought a couple of thoughts into this talk that derive my perspective on computing in general. Then not all of this may be deeply scientific, but I think at looking at the field for quite some time, I think it opens some good discussion points. I begin with the following. I say that computing has mainly failed its big promises, and that is providing genuine value for human users. And to bring a couple of examples why I think that while computer science was able in the last 30, 40 or longer years to deal very well with the technical problems they tried to solve, but not so successful with the promises for individuals and society. And the research that I present later in more detail is just one example where we as a group try to counter these effects. So what were statements in the past of promises what computers will bring to us individuals and societies? One is famous one from the 90s, that tech at one day will step into the background and help us to better focus on the real world. As Meisner said, the world is not a desktop, and that in the future we should make computers more invisible and make people concentrate on what is really important in life. So what did we get 40 years after? The world has become a desktop, and it seems that computers are more in the foreground than ever before. And this also leads to problems like smartphone addictions. Scientists say it leads even to brain rot, all this scrolling through the reels and so on. So I don't know, is it even relevant today to think that, okay, let's generate a future where computers are more in the background, or is it just the desired reality that we have today? Another example is a couple of years later is the cool things that social media will bring to societies. They will foster democracy, empathy, and human values. And there were some examples that were like positive ones, undermining these ideas like the Arab Spring or the election of Barack Obama. But is this really the reality that we have today? Maybe not. So social media is undermining democracy, it seems, even up to the point where it's contributing to genocidal activities. So when we think about the technology that is promised us today, AI is so great, it will make a better world, it will solve our problems. We have to ask ourselves, can this even be true? When we look into the past, how realistic is it that these promises will be satisfied? So one thing that is said is what AI is doing, it will allow us to make us get rid of all the repetitive work that we are doing. It will free our mind to foster creativity. We don't have to work anymore. We can write poems all day or make paintings. But the reality that we got is that AI is now writing the poems and doing the paintings while we still do all the stupid repetitive work. Sam asked, are we living in the golden age of stupidity? So I don't know if I should trust all the bold statements of these great AI engineers. This brings me into this field of multitasking that we're working on, and that is strongly connected to some of the problems that I've already shown to you. So I say we live in the age of disruption. So we constantly are engaged in smartphone activities. You may know these situations where you sit at a family dinner and somebody says, is it really necessary now that you reply to your WhatsApp messages or are in contact with other people? Reality is here now at the table. Or the questions that I also like to ask, where Salzburg is somehow countryside. You all have a driving license, right? So who uses a smartphone in a car? Yeah, everybody, most people do at least at some point, although it's forbidden, right? We know it's illegal. If a policeman sees us with that, we even get fined. But somehow the technology itself is so addictive that despite all the risks, and the risks are high and the stakes are high in a car, we still engage in these dangerous behaviors. And we did quite some studies in the past, particularly in the transportation domain, where we looked into the effects of device usage in smartphone and what it means for safety in, let's say, an automated car, like in that example. So in this study, we made people respond to what we call so-called takeover situations, meaning this is, you can imagine that you have an automated vehicle that at some point has a failure or any other reason that requires you as a driver to take back the steering wheel and re-engage in the driving task. But at the same time, automation promises that when you have this automated car, of course you can use your smartphone. But when you have your smartphone in hands and when you're cognitively engaged in any other activity, will you then be fast enough to safely respond to such a request? And to find out in that experiment, for example, we built this semi-automated vehicle with some fancy technology, and we had different conditions. In one, people were reading on a smartphone. What you see on this smartphone is so-called reading span tasks. So users have to assess the semantic correctness of different sentences. One is like, in the summer, the birds fly into the south. That's green button, semantically correct. While the elephants fly in the south, no, that's not a correct sentence. So we have to realize that, press the red button. So this reading comprehension task can be used to somehow also measure, depending on how good people are in detecting the semantic failures, engaged in the task. And at the same time, suddenly this takeover request was coming, and we had a very interesting setup. You can see this balloon car. It's like big inflatable back of a vehicle standing on a robot platform, and this robot platform randomly drives between these two lanes. So when a driver could come around the curve, they could never know before, do I have to go left? Do I have to go right? They have to quickly remove their smartphone, grab the wheel, and do the reaction. And it's quite obvious that when people were engaged in smartphone activities, they performed way worse in these kind of responses in comparison to, let's say, they would just listen to some audio, or they would do nothing at all, just look out of the windshield and see what the situation would bring. And it's just one out of many studies that have done by us, by other groups, showing that device usage can be very dangerous, even with semi-automated vehicles. But it's not limited to that. So that is a study we did with bicycles in the city of Vienna, where we asked people to respond to messages when they would feel safe on that bicycle. The trick here is it was a tandem bike with an experimenter at the back who was always trying to maintain the safety of the experiment. So this allowed us to really make people use the smartphone and respond to these messages. And what you could see here is that over time, when people did it once, twice, a third time, at some point, they were no more even looking in the road environment. They were just replying. So we can see that with these and other studies, also natural studies or studies done where people have put cameras somewhere to bike paths and look at what people are doing. And smartphone use on bicycles is also increasing. It's also not very safe. With the bike, we even have the problem that the person using the smartphone is at the big risk, right? So if you're in the car, yeah, maybe there are less, more vulnerable road users that you might strike, but on the bike, it's your own safety. There's a very high risk. But we don't have to go to the safety critical domains. We did a recent study at our university where we monitored people over 1 hour of dedicated work to find out what are they actually doing in their work time. So we made these videos of people. That's a video from my computer, so it's allowed to share it. And then we made people annotate their data to see, okay, when did they use a smartphone? When did they switch between different apps? Why did they switch between different apps? What did they do? Management didn't like the results of the study a lot. So what we could see is that only for about 60% of the time people are working on the tasks that they're supposed doing, on their primary task. And you can see on this density plot here on the right that most of these activities didn't last longer than 2 to 3 minutes. After that time, people were already doing something different. So the good thing is that in many cases, people were switching to what we call an on-task activity, something that is at least related to work, like getting information on the web, talking to ChatGPT about, okay, how can I improve my paper, and then going back to Overleaf and write that down. But in a big number of cases, like 22% of the time overall, people were going off task, like taking the smartphone, watching this nice cat video that somebody was sending or replying to a message. And the problem here is there is always this danger of having this off-task loop. So when there is one cat video, there is always another cat video coming in that I continue watching. So we know that the accumulation of these effects leads to significant productivity drops at workplaces. Often people do, I'm not affected by this problem, I use silent mode, but with our data, we could see that people having silent mode on sometimes even more often took their smartphone because they wanted to know if somebody has written them in the meantime, because there is no notification, right? So looking at all these studies in these different settings shows us that multitasking in different environments can be very safety critical, produces high socioeconomic costs. That's interesting. I have here still this line when I started this research quite some time ago. Each smartphone receives more than 60 push notifications per day. Just 2 weeks ago, I think I reviewed something where they spoke about 150 or something. So this is like a 10-year-old number, and it's even way more these days. And we know that all this switching between different activities, that on the long run, this decreases our performance and leads to higher stress and error rates. And as I'm addicted myself, and as I am suffering these problems too a lot, I thought, okay, this is something that we could work on. Could we build some cooperative AI system, a so-called attention management system, that would help us to mitigate these negative effects and make us better multitaskers? So when we have such a cooperative AI system that would decide for us what we would do at a given time, then this also raises the question, what's happening with my user autonomy here, right? It's no more me deciding what I'm doing. Suddenly it's a system deciding. So a big question here is also, would users accept a system, a cooperative AI system, that would design upon their workflows? In the next 10-15 minutes, I will show you a couple of the work that we did in this field. So we began very easy with a simple balancing task that I showed many times already. So idea is fairly easy. You have 2 platforms in a game, and there are 2 balls, 1 ball on each platform, and these balls at some point would fall down these platforms, and you with a gamepad, you have to prevent that any of these balls would fall down. You can only control 1 of these balls in any given time, so you have to switch the task from one platform to the other to maintain these balls being on the platform. And like Tetris, the balls are becoming faster over time, the platform gets more slippery, so at some point you will just die, so to say. So this is like a multitasking situation condensed in this gamified environment. So we asked, can we make an attention management system that would do the switching between these platforms for you so that you would be better in the game in the end? This creates an additional problem that I briefly want to touch upon. It's like we use reinforcement learning, an AI method, to train our agent, and these agents need training data. And you can imagine it's hard for me to, let's say, put you all in our basement and let you play these games for 2 weeks or so, because we need a lot of training data. And if the training was not successful, we tweak some parameters, and I ask you, please go again into this basement and play this game for another 2 weeks. So to train our system, we need simulations of human users that play the game, but somehow behave realistically. And to do that, we use the concept that is called the computational rationality. And that is based on the simple idea that while the classical AI research tries to build AI systems that are as good and as performant as possible, computational rationality goes the other way around. It asks, how can we simulate limitations of humans for the AI to make these AI systems behave more human-like? Imagine it as follows. When you as a player play this game, you can only look at one of these platforms. You can't see the other one, or just peripherically. So you cannot really see what's happening there, while a traditional AI system would just see the whole screen and do as good as it can. When you would make a movement with your hand, it would need some time to move your thumb. An AI system could act instantly. When you would try to look at the other platform, it takes your eyes a little bit of time to move there and focus on this other ball. And these are limitations that we, our bodies and our cognitive systems suffer, so that we cannot play this game as good as a traditional reinforcement learning agent. And if we model these constraints into our system, we can generate human-like behavior. It works in the following way. You can imagine that here's a 2D version of this ball, and here we simulate a user that is distracted. And we have a probability distribution that you can see with these red bars on where our simulated user believes the ball is. It believes the ball is there because here is the highest probability. It's slightly off where the true ball is. So this represents a distracted user. But we can also model how the situation would look like when this user is attending the task, when he's focusing. Then we remodel this probability distribution to make it very close to the true state of the real environment. You can see this in this video here. So you see this pigmented ball always being a bit in front of the belief state of our simulated user. So this white ball that lags a bit back is where the agent believes that the ball is. And on this green platform, where the simulated user is focusing on, those are always very close in sync. While the blue platform that is not attended by the agent, over time the deviation increases between where the ball really is and where the simulated user believes that the ball is. This also means when the user switches back to this other platform, it needs a short time to synchronize these positions again. So with that system, we can somehow realistically model the delays that we humans face when we switch between these platforms. And we trained our agent with this kind of concept to achieve that system. So this is Alex, the student working on this project, playing the game with the trained model. So now the system is switching between these platforms for him, ideally in a way that he would not go game over as fast. And we tried that out in a user study with a large number of people, I think about like 43 or something, comparably large for a typical HCI study at least. And we could see that indeed our reinforcement learning-based attention management system could significantly improve humans' performance in the game, and they could last for up to 1.5 times longer playing it than in other modes. So we see, okay, that was quite successful. So the next idea is, okay, let's make this a bit more realistic. Playing this game has nothing to do with the driving, biking stuff that I showed you in the beginning. So the next thing we did is like, adapting the system to manage messages on the go. So like what I described before, I would walk around like to my morning office and I would get messages from my wife, from my child, from my coworkers, and I have to decide what's the most important message to answer first. Is it my wife's? Is it my boss's? Complicated decisions to make while I'm in this safety critical environment. So would an attention management system based on the same principle also help us here? So here our goal was, instead of just performing very good in the game, completing messages as fast as possible. It's also not fully realistic of what counts in the real world, but it's the next step towards it. And our attention management system should schedule these incoming messages in a way to maximize that performance value in terms of accuracy, priority, and typing speed. And for that, we made a bit more complicated model. So we now have a vision agent that uses the pixel stream of the smartphone to decide where to look at, and we have a typing agent that simulates moving between the characters on the keyboard. And you can imagine that, you can see it here on the right, when the simulated user is looking at the text, they are not as good in typing anymore because they don't know where their thumb is, but when they look at their thumb, they make less errors in typing, but don't remember as well what they were writing. So that is able to also simulate the typing activity in a very good way. And so we trained this system again here in this study environment. People were walking around on university campus and there were no real dangers in the path because here there is something called ethics requirements for user study that would prevent us to really put people in these dangerous situations. So this was basically a repetition of this kind of a ball balancing game that I showed you before. But the good thing is the results were quite the same. So with the kind of system, we could see that people had a significant higher typing performance and also less reaction time when they were switching between these messages. Some are also logical because the system would decide for you which message to answer at what given time. And we could also see that this, of course, decreases the workload of people because they have less to do less decisions themselves. Interestingly, or what's like a good sign for this attention management system, is that in that scenario, people preferred that kind of support. That was quite different in this balancing game I showed you, because here people said, I mean, that's a funny game to play. Why would I want to support in such a gamified environment? I would rather play myself than use the support of this system. While here in this messaging while walking scenario, people, let's say, in this using subjective scales for user experience and also interviews here, that's quite a nice system. I could imagine to use it on the go. So with these two studies, we showed that like cooperative agents that are trained on cognitive models of human behavior can support users in complex dynamic situations where decisions must be made under uncertainty. And multitasking is just one example of these. I want to spend a few more words on this question of user autonomy and if people would really be willed to accept such a system. So one basic idea we had is like, if we upscale that and make it really a real-life use case, it would work the following. I would, let's say, be here now, and if somebody would send me something, the system on my smartphone would just say, I don't need to notify Philip now. I just be calm until this presentation is over, until I'm sitting back in the train or whatever, and then the notification would come. There would be no need for me to put my phone in silent mode while I do this presentation, because my system would know it shouldn't disturb me at that point. Disturb me a lot in the meantime, actually. But the question is, of course, this doesn't account for every message, right? It's depending on who would send me what information in which context. So we made a vignette study with many variations of that scenario, where we always said, let's say, assume you're sitting with your friends Saturday evening, you watch the movie, and your boss, your wife, your friend, that's a variation of the vignettes, would send you an information with a particular level of urgency. And then you could decide on a slider, how long would you be willing to let this message be delayed? A couple of seconds, minutes, even hours, or until the next day, potentially. And we did this for many different situations and also asked, like, how would you accept if the system would behave that way in that scenario? And also, what kind of sensors would you allow such a system to use? It could use just, okay, the content of the notification. It could use biosensors attached on your smartwatch, or it could, like in a workplace environment, have a camera somewhere that would directly look at you to identify what you're doing. And what we found out is, like, especially in these safety critical and work-related settings, there was a high acceptance for these kind of systems. Less in these private environments, less for private contexts. And users would permit delaying notification, particularly for non-critical everyday messages, from both private and professional contexts. Although many said, I want to have like something like an emergency button. I want to say, this is a very important contact for me, and I would never want the system to manage the notification for this person. At the same time, users said they would grant access to data from various sources, like operating system data, what I'm typing, what app is active, also physiological measurement, like eye tracking or fitness data. I think this was very interesting for me personally, because when I was a student 20 years ago, I had this impression that physiological data is very privacy invasive. I would not want any app to use that, but it surprised me that somehow this has changed in the last couple of years. In contrast, videos were not very supported by the user group. So they did not want some system to continuously watch them to make these kind of decisions. And we are currently conducting more of these studies to find out in more detail how such systems could look like. One thing that we're experimenting with, for example, is it's kind of this metaphor of having an AI secretary. So if, let's say, you would write me something, you would first talk to my AI secretary, and this secretary would try to find out how important that conversation currently is and if it's really necessary to disturb me, so to say, with a similar kind of questions like what is important, which contexts are important. But I will not go into the details here. Maybe you're one of the reviewers, you never know. Okay. So with these kind of studies, I want to emphasize that we're not just looking at these technical aspects and how we can make these kind of systems possible, but we also look into the question of user autonomy and how people would accept these kind of tools. But we see, okay, users would welcome cooperative agents that support them to maintain their focus, manage interruptions, and control information delivery. So this brings me to my final slide here. Why don't we have these systems already? Why would we, as a small research group in Austria, even look at the problem? And there are two answers to that. One is, we have attention management already, but there is a different goal. The tech companies, they try to maximize your engagement. So they do attention management in a way that you provide their attention to them all the time, or as high as possible. And there are also other reasons that somehow link back to these problems that I showed you in the beginning. So one is like wrong incentives of computing technology. So we as users, we're no more the real customers of many software applications. We're just a product or byproduct of many services. So these companies earn their money by selling our data, but not necessarily by making our life better. I also claim that there is a lack of vision. So we need a larger discussion again on what the role of technology would even be in our lives and how the future, or an utopian future, could be. I remember that, let's say when I was a child, when I was a student, there were these like big companies, Apple, Microsoft, fighting on the market about the customer. And many of these discussions I had back then with friends who were more on Apple and others were more on Microsoft. There was like, okay, who has the cooler features in their operating system? I wonder why I don't see these discussions in that depth and detail anymore these days. Maybe the user is not that important even. So when I see tech giants today about what they discuss, I don't see the user being in the focus that much. And finally, there's also missing regulations. So regarding computing technology, we are still in like a Wild West phase. I always like to compare it with car driving or vehicles that were invented, let's say 100, 120 years ago. And there was a long phase in the beginning where there were just no regulations. Everybody could drive at any age if they could just hold the steering wheel. Driving licenses came very early in comparison, but let's say that you're not allowed to drink was very late law, I think in the 50s or 60s in Austria. So it takes a lot of time between when a technology becomes mature until the society realizes, ooh, there are some problems that we urgently need to solve, so let's invent some regulations to make that better. And I hope that regarding computing technology, that before I'm dead, we see some regulations that make this world a better place in that regard. Yes, and with that, I'm finished with the presentation, and I look very forward to having engaging discussions with you. Thanks.
Who would like to start?
So, what I would be interested in, you just asked, like, why do not we have this already? And I have this feature on my iPhone, and I have no idea what it does. But it says, like, if I want notifications on time, and then I can say, like, critical notifications or time urgent notifications, and then they will pop up even if my phone is on silent. Have you taken a look at it? Do you know what it does?
I know these kind of systems, not that particular feature in general. Why don't you know about this feature? Or do you use it?
So I just have it checked. The only thing I use on purpose is that I have two people that where from those notifications will always come through when I'm on silent mode at night. But for those, I did not pay attention at what exactly, how they would define a critical feature. But it shows that there is something like this out there.
There is something out there, and there are also other systems. You can download apps where you can configure yourself in very high detail for which time, for which person these systems would deliver you notifications. But one thing is, there's a high configuration effort needed to really get somewhere useful, and it would still not guarantee that in a critical moment, maybe this important message is coming from one of the contacts that you haven't configured. Maybe in another situation, there is some contextual variation that is not covered by that system. And what many of these very static rule-based systems have is the problem that they don't really look on your dynamic situation with high resolution. So what we know is that whether an interruption has a very degrading effect or not is sometimes just a split-second decision, or like in 2 or 3 seconds later, the situation could look very different because maybe you're focusing on something different now. Maybe you're in a more interruptible state now, and that is at least not covered by these kind of tools. But of course, the problem is big, and there are also, I mean, the simplest way is like going in silent mode, and there are different levels of system complexity. But currently, many tools that you can use, the more detailed and the more complex they are, they also have like a very high configuration effort. So this is where we try to improve the situation.
So I still have to research what this feature does.
Potentially, but I mean, to be fair, we also did not provide good explanations what our system does. So in that sense, our users were not more informed about about the system design.
Hey, I think it's really cool how you designed the studies. I have a question about the game with the 2 discs. Did you also check whether after a while people were playing with the assistance of the AI? Did they get better without the assisted system afterwards?
We actually had even a study and a paper on that, and I don't want to make wrong statements. I have to look it up. I think it worked in a way that with or without the system, we had a very similar training effect. So we could not really show that training with the system in place would have a better impact on the learning than not having that system. So even playing without it would make you a better player.
Any other questions? Moritz, please.
What made me think, like, you showed how you trained, like, on these platforms, the balls, and the balls are always behind. Why are they always behind? Isn't it also that other people might have the opposite time perception where the imagined ball might always be further or closer to the border than it actually is. Like, we all perceive time and movement differently. Did you take a look at this, or like, how did you come to this assumption that you always think it is further back than it actually is?
I mean, that whenever you see reality, the time of what has really happened has already passed to some degree. That's not an assumption, that's just reality. I agree that what you're describing here is some kind of a playing strategy in terms of when I know where the ball might go, I could try to react a bit early because I predict the state of reality into the future. We did not have that in that kind of agent. What we do have is that these models can be configured. So for example, depending on, we could say we can model a user with a very high and a very low reaction time, like a young, very healthy person compared to an old man like me, who has a longer reaction time, and we can configure the system in a way to model these fast players and these slower players. And what we're currently also trying to do is to infer these parameters while people are playing as fast as possible. So this means if we give you the game, that the system would understand after hopefully just a couple of seconds or minutes what are the configuring values that would represent you as a player in the best way, and this can then be adapted by the system. In the study that we did, we just took an average user for all the participants we had. So in that sense, there could even be a better system performance by taking these individual variations more into account. But I mean, the models are quite complex to implement. So any feature that you add, and there are many plausible features and many plausible strategies, then the system gets, of course, more complex. So we try to take the minimal set of assumptions here, perception and motor control, to make that possible.
Hi, thank you for the great talk, for the inspirations. I want to challenge you with respect to two of your statements. The first one is a little bit broader one, which was not made by you, but you cited somebody. So you were saying that people nowadays want the AI to do the laundry and not themselves, and they want to create poems or do drawings. If I look back a few years or well, maybe not a few years, decades, people were doing the laundry on their own without any washing machine. Yeah, and nowadays we have washing machines, we have laundry machines, and we are not and these people are not using the time right now they have to do poetry, but they use the time to look into social medias and to look for cat videos. So it seems to be not the case that people rather want to do poetry on their own. If they have more time, they want to have more time to look at cat videos.
Yes.
Are you in line with that? Because that contradicts a little bit with what you have been saying.
Okay, yeah, then maybe I miscommunicated a bit. What I wanted to say is that there's like a promise that computer scientists and engineers made on what the future can be, in a way like you will not need to spend as much time with the tedious task like doing the laundry, and you will have more free time to do whatever you think is best for you then in the end. That this doesn't have necessarily to be to write poems, of course. It can also mean just to stupidly watch through these cat videos. But I still want to question the assumption that we always know best what's really good for us in a way, right? And I think I'm allowed to say that because I think it's fair to say that I'm also addicted to a lot of these smartphone contents. But for example, there are these kind of situations where, let's say we have a family weekend and I promise to my family to just leave the smartphone in the car for the whole weekend. I know that when I just would take it with me, I would constantly watch, I'm not a cat person, not cat videos, but something different. But when this weekend is over, it really makes me feel that, okay, this was actually a good idea. The time felt more valuable for me personally. So I think we have to reflect more as individuals, but also as society, what level of computing is healthy for us.
Thank you. May I have a second one? Yeah. Second one is related to one of your works. So on the study that you did for efficiency of work or effectivity of the work that you have been doing, you were saying people were concentrating on their task for a certain amount of time. I can imagine that I go to grab a coffee or to go to the toilet or to talk to somebody, and I would say that increases my productivity. Your assumption seemed to be that if I'm working on a task for quite some time, that I'm more efficient. Yeah, you said 60% of the time people work on their tasks. I would say I need the other 40% in order to be efficient for the other tasks. Yeah, we also say that if people are sitting in front of a screen, they should not look into the screen for an hour. They should look outside and look into the woods or whatever they are doing. I think we as human beings need those times. So I think that's not a problem that you stated. And do you really want people to sit there for hours being more efficient, claiming that they are more efficient? Yeah, I think these in-between times are needed for us, for human beings. So aren't you on the wrong direction here?
No, I don't think so. So I think that one part of it, one reason why we employed this method with the videos was that we wanted to also be able to look into things that happen not on a screen, for example. So if you would talk to a colleague, and at that level of detail, as I had it in the slide, there was not all of the coding. So we had, unfortunately, in this whole data set, not too many of these analog activities to really make an evaluation of it. But I would, for example, say that if I would have to annotate my own data, and I would work on my task, and I would log out of the window for some time, then I would not annotate it as a deviation from my primary activity. Maybe I was thinking about what I'm actually doing. That's point one. Point two is, the idea of all that is not to make the 60% of the hour 100%. It can be the 60%. The real problem that is underlying here is how long people spend on one of these individual chunks, and in how many weird situations people tend to do suddenly something different. Because focus is one argument here, and another one that I always like to bring is the kind of a flow state. You all know flow state, right? If you do something very concentrated, like running, like working on this document for a sufficient time, you get into this phase of concentration where some people say you are more productive than like before. When you look at flow state research, you will see that flow state cannot start sooner than, let's say, 15, 10, 20 minutes of dedicated attention to one activity. I don't know the exact number. I'm not a flow state researcher. But what I know is that it's never 3 minutes or less. So trying to make people have these chunks a bit longer, these focus times, I think that is the core thing that we need to look at. It's fine if you work for half an hour on your document and then you do some Facebook for 5 minutes and talk to a colleague for another 15 minutes, but this constantly hopping back and forth, that's the most degrading thing that we want to hint at with these studies. And that's the productivity loss that I would argue. It's not the overall time, it's more you can better distribute the things that you're doing.
Just want to make a quick follow-up on this. Flow is one thing. The other thing is aha moments. And aha moments are very important for creative breakthroughs. Those tend to happen not while in a flow state. They tend to happen when you have multiple stimuli coming at you from related fields, from fields where you see structural similarities. So I think I'm following what you're saying. It's not necessarily that there's one thing that is better than another thing. It's a question of which context am I in, and what is it that I really like to have right now, and then to have a system like this that actually helps me to achieve that, that would be very, very helpful and beneficial, I think. But I'm also skeptical on the question of regulation around these issues. How do you regulate this? This is touching so quickly on my own personal space and liberty. I would be very careful there. But that's not to say that I don't think the studies are very helpful and useful, and it would be great to have these kinds of tools.
Yes, let me comment on this regulation part. So I think with that comment that I made in the end, I want just emphasize my opinion on the general relation we have to technology and how in many ways it has altered our reality. I didn't mean per se that there should be a regulation for having such a system for you at home when you do your work in your home office. However, what if you are, and we had that scenario, you're an air traffic controller at Salzburg Airport. There can be a regulation. There can be a regulation on how you use your smartphone in a car, because there are two options. Either you're just not allowed to use it, or you're always like breaking the law. But if you have a regulation that would make it possible to, at least in some situations, get some benefits of that technology, it would be a win-win for many sides. How regulations could look like would depend on these other problems, for example. So I think that social media urgently needs some form of regulations. And I'm not sure how these regulations would be. I think that often when we think about AI and algorithms, regulations are communicated in a way that somebody needs to be able to look into the algorithm of what the private company sells. And I'm not sure if that's per se the approach where we should go for these kind of regulations. I come again with the driving analogy. So if you want to build and sell a vehicle, there is a number of standardized tests where you have to show a government agency that your vehicle is able to pass these tests. This agency doesn't care how the technology really works, how you achieve that, but they need to pass these tests. And I think there can be similar kind of tests for all kinds of computer systems. For a social media, and it could be, and I'm just saying something here because I'm certainly not the high-level experts on the topic, but some studies have, for example, said that to counter polarization on social media, it would help people to also expose them to different things. There are also studies counteracting that idea, so I'm not making definite statements here. But if that would be the case, it would be fair to say, dear Facebook, you can use your system, you can sell your system, but you have to confirm, and we will test that after a particular time, you can guarantee that people would just not fall into a filter bubble, for example, because they would be exposed to other contents too, kind of. Or there could be a regulation that would prevent you to, not just in a private message, but like in a public comment that you make, that you would harass other people. And with today's technology, that can even be achieved. I don't know. As I said, I just think it's something that we could think of, because on the long run, we have regulations for everything in our society, but just not a lot for computing technology.
Thanks for the talk. What I really enjoy about the work is that really fundamentally it seems to ask what it means to be human in kind of a hyper-technological society where you get bombarded with notifications, bombarded with data. And it seems that beyond kind of the technical problems, it's a deep political issue, right? And all the odds seem to be stacked kind of against us in the sense of the incentives of the companies are to attract your attention, to have an AI or a government kind of deciding for you risks, basically giving up some of your freedom. And then even when you do have all of that freedom, you kind of choose to watch cat videos or do these sort of things. And For me, so I work in extended reality. I'm working at Qualcomm. We're making AR glasses and so on. And I think both myself and my colleagues are kind of horrified about what we're working towards in some sense, just looking at how this might amplify the problem. So I guess I just wanted your thoughts on this. How do we deal with this as
Yeah.
a society, I guess?
I don't know. So I'm pretty sure that I'm not the one who is able to solve that problem. I just think that it's necessary for all of us to really think about it, and also try to ideate solutions. I mean, all of us can do that, right? I once read that Bill Gates and Mark Zuckerberg, they're not giving social media and smartphones to their own children. So there is something that you can do in your private life to make the world a whatever place. I don't want to call it better per se, like that would be too normative. But this, what I mean is, like, you can make individual decisions for yourself and for the people close to you. You can also engage in discussions, like with people you know, or in just more public spaces. Because otherwise, I see it as you. We're making the situation worse and worse, because many of some of these examples, they are quite from the past, right? Social media is not a tool of today. It's now a 15, 20-year-old tool. And we can see now what are the downsides of it. So my prediction is in 20 years, we will see the big downsides of, let's say, generative AI, where scientists tell us today, hey, your kids' brains are rotting away. This was kind of one of these news headlines, partly because of addiction, partly because of the social media, partly because of the Gen AI that make people not think that much themselves. So with AI, with AR, there's always a new technology coming up. Why would it automatically become better? I don't see that happening. So.
Can I have a quick question on the first experiment with the balancing the balls? So just to make sure I understand that the AI, the RL agent, is switching between them automatically, and you're just controlling. Yes. Would it make a difference if the RL agent only highlighted, but you had to make the switch between them? So the extra kind of decision of making the switch?
That would make a difference. So we had that condition in both of the studies we did. So for these selecting the messages on a smartphone, it still made some performance increase, not as high as with the automated switching, because just the action of doing something already benefits you some time. It didn't work well with the balancing game, because they're just so fast-paced, and you have to go back and forth that until you realize you need to go to the other platform, you may even have to go back already. So that one confused people even more than it helped.
So I think we have time for one more question. Any questions? Then I would like to
Come
ask
on, one more. I mean,
Yeah.
it's just one
No,
question.
I have a few. One of the things is, what did you look at? But always strikes me when it comes to those systems, is that self-perception. Like everyone thinks they're awesome drivers. So what does it? Everyone thinks it does not apply to them. So how does this really play into this? And I think to a certain extent, those systems are actually exploiting this situation. That your self-perception is really off. You're lying to yourself. To what extent you're capable of, and to how you can focus your attention.
I think that is true. I don't fully get how it could really influence that. I mean, I see it in a way that's happening, right? Because when I ask people these kind of questions, if I had more time, I would discuss why you would use a smartphone. And people often say, I'm not the danger here on the street. Everybody else is, because I know how to handle it, right? But in the end, nobody really knows how to handle it. Or you know it in 99% of the situation, but there could be this 1% where there is this kid. And then, yeah, you have a very miserable rest of your life, because you can never forgive yourself for just looking at your smartphone stupidly. I don't fully know how we could make these kind of ideas benefit from that, but I'm happy for any suggestions, let's say.
I'm wondering about that a lot. So thank you very much for your talk. Thanks for coming.
Thank you for
Thank you for
inviting me.
inspiration.
Thanks.
Thank you.